In this video, we demonstrate the creation of a city map using the process developed in the paper Interactive Procedural Street Modeling. The process starts with the input of a water land map and a street density map. An initial tensor field is created based on the boundaries in the water land map. The first step in creating a new city is the design of the tensor field for the major roads. In our system, the user is able to insert tensor elements which represent road patterns. Here we demonstrate the insertion of regular elements to create a constant field and a regular grid pattern. Notice how the region between the elements blends smoothly between the directions specified. Beyond regular elements, we offer several other patterns, such as the center. Our tool also allows the editing of elements placed into the field. Here we demonstrate the move and edit operations. This allows the user to make many final adjustments to the road pattern before extracting the road networks. We will demonstrate later that we can also remove elements. At this time, we are ready to extract the road networks. Typically, tracing takes between 5 to 10 seconds on a Pentium 4 3.2 GHz processor. Once an initial road network has been extracted, the user may continue to make edits to the tensor field. In this example, we add noise to the right side of the map. When the user is satisfied with the major roads, generation of the minor roads can begin. To edit the minor road tensor field, the user will typically segment the edit area into several small regions based on the major roads. Each of these regions can be edited separately. Here we show the removal of an element. Notice how the tensor field remains the same even after the element is removed. One operation unique to the segmented field is the ability to sweep a tensor element across multiple regions. Notice how the operations available to the major roads are also available to the minor roads. The editing process continues until the user is satisfied with the attend field and road network. One useful tool for creating unique road patterns is the brush interface. The interface lets the user paint a strip of roads into the field, thus producing roads which do not match a global pattern. When happy with both the major and minor road patterns, the user can compute the final road network. This combines the major and minor road networks, removes unwanted dead ends, and creates a street graph. With the calculation of the street graph, the city map is complete. This shows our process can create a reasonable street graph in under 5 minutes. In the next section of the video, we will show how to use local editing to insert a park into a pre-existing map. We start with the street network that was loaded from a file. The user first selects the region for the park. Once the area has been selected, roads within the region are removed. A new tensor field is designed in the region. Here we add noise to the field, but any editing operation could be performed instead. Once the field has been generated, the roads are extracted from the field and a new road network is computed. Note how this new street network is connected to the old, creating a complete network that includes the original and newly generated sections. Finally, we leave the viewer with a flyby of the virtual city we generated in this video. For aesthetics purposes, we have added parks to the texture map. We wish to thank Andreas Ulmer for his help with the rendering and modeling of the 3D cities. Our appreciation extends to discussions with William Brendel and to Medusa Danan, Srinivasan, and Patrick Neal for helping in preparation of the video. We are also thankful for the support of the National Science Foundation, Oregon Department of Transportation, and a grant from the NGA.